Hello Math 1093, this is Dr. P with Working on That Tan. As you're about to find out, that is a very cheap pun. In this video, we're going to introduce the idea of proving trigonometric identities. Let's write that down. So, proving trigonometric identities. Alright, so first of all, what does that even mean? Identities. There we go. So what does the word identity mean? An identity is an equation like, let's say, for example, x plus y quantity squared equals x squared plus 2xy plus y squared. This is an equation that is true for all possible values of the variables. And we can contrast that with an equation like, let's say, 2x plus 5 equals 4, x minus, let's say, 3 or something. I'm just picking random numbers here, honestly. That's an example of an equation. This one here is an example of an equation that can be true depending on the value of x, but really it ends up being true for only one value of x. Whereas if you look at this equation here, this equation is true no matter what x and y are, as long as they're real numbers. So that one we call an identity for that reason. And a trigonometric identity is just an equation involving trig functions that is true for all values of the variable. And we're going to talk about how to prove those. Now, you've probably heard of the word proof or prove in mathematics before. Underline that. Okay, so what does it mean to prove something? In this class, all it means to prove something is to give a clear and convincing algebraic argument that identity is always true. That is, that the two expressions I give you, like this one and this one, except these will involve trig functions, prove that those expressions always represent the same number or the same value. So that's what we're going to do in this video. And I thought a good way to start would be by talking about one of those Pythagorean identities that we had introduced earlier, but that might still not be quite that familiar. Alright, so you may remember from our previous work that we know that sine squared of theta, or let's say sine squared of t, plus cosine squared of t is always equal to 1 for all values of t. And because that equation is true for all values of t, we call that an identity. And in fact, that one has a special name. It's called the Pythagorean identity, or it's one of the three Pythagorean identities. But you may recall there are two other ones. What are they? One of those other identities is the equation 1 plus tangent squared of t equals secant squared of t. And we might try to prove that identity. Now, one thing that we may have talked about previously is that one way of proving this identity, if we believe this one, and this one, remember, we talked about and we established just using geometry. But if we have this one, we can turn that into this one by dividing both sides by the cosine squared of t. That would be one way of getting from here to here. But I'd like to illustrate another one, because let's suppose that we didn't know that trick. Let's suppose we didn't know that there was that special move for getting from here to here. Is there some way that we could work with this equation that would help us to prove that that is true? And yes, there actually is. One way of working with this equation is to start with one of the sides of the equation, either this one or this one, and try to manipulate it so it ends up looking exactly the same as the other side. Manipulating it by doing algebra that does not change the value of the expression. Okay, so what we're going to do is we're going to try manipulating this side of the expression, keeping it equivalent to itself, keeping it equivalent to its original form, so not changing its value, and show that eventually we can manipulate this or massage this until we get secant squared of t. So that's what we're going to try to do. So let's just start by doing the one thing that would make sense to do here. So let's say we just start with 1 plus tangent squared of t and look for ways to rewrite this. Well, the only way I can think of rewriting this that isn't just to use this this Pythagorean identity here, so we're assuming we don't know that yet. Well, one way of rewriting this is to rewrite this in terms of sines and cosines, and it turns out that's actually a very useful strategy for doing these. So I can rewrite 1 plus tangent squared of t as 1 plus sine squared of t over cosine squared of t. By the way, the reason that's true is that tangent squared of t, I just want to make sure I'm justifying this step clearly. Well, tangent of t is sine of t over cosine of t, and I'm squaring that entire thing. If I square that entire thing, that's the same as squaring the numerator and squaring the denominator. So I just want to make sure to include that algebra there in case that needed justification. Okay, so anyway, I have now 1 plus sine squared of t over cosine squared of t. So now I have an expression where there's this whole number here, this 1, and then there's this fraction here, and I want to add those. Well, usually the way to do that is to try and get a common denominator, even though that makes things look a little messier at the beginning. So I can get a common denominator by making everything have this denominator of cosine squared of t. So that's what I'm going to do here. I'm going to change 1 into something that's equivalent to 1, but has denominator cosine squared of t. Okay, that is certainly another name for 1 there. It's cosine squared over cosine squared. And I'm adding sine squared t over cosine squared of t. Okay, now I'm adding two fractions with the same denominator, so I can combine them and just write the sum of the numerators up top. So that's by fraction addition. And then once I have that, I'm like, oh, wait a minute. There's that Pythagorean identity that we had earlier. Cosine squared of t plus sine squared of t. And I know by geometry that that numerator is always equal to 1. So I've got 1 over cosine squared of t. And that's the same as 1 over cosine of t, all of that squared. And I know that 1 over cosine of t, that's equal to secant of t squared, also known as secant squared of t. Now, one thing that I did there, actually in this process, I used a couple of different identities that I want to point out here. So I'm going from tangent of t to sine of t over cosine of t, that is rewriting tangent in terms of sine and cosine. I use something called the quotient identity. And honestly, I don't care too much about remembering the name of that. I just want to point it out because my math lab uses that name. The quotient identity says that tangent of t is equal to sine of t over cosine of t, because we would call it quotient because it's saying tangent is the quotient of sine over cosine. And there's also a quotient identity for cotangent of t. That would be cosine of t over sine of t. Okay, and in going from 1 over cosine of t to secant of t, I use something called the reciprocal identity. And the reciprocal identity is just saying that the secant of t is the reciprocal of cosine of t. That's why I can rewrite this entire thing, this 1 over cosine of t, as secant of t. But anyway, so let's just take stock of what we did here. We started with 1 plus tangent squared of t. We did a bunch of things that were just rewriting various parts of the expression. So going from here to here, we just rewrote what tangent of t means and then squared it. Going from here to here, we just rewrote what 1 means and didn't change its value. 1 is just cosine squared of t over cosine squared of t. Going from here to here, we just added the two fractions. That doesn't change the value. Going from here to here, we used the Pythagorean identity on the top, the one that we had from earlier. And then going from here to here, we just did various little algebra things. And going from 1 over cosine of t to secant of t, we just used the definition of what secant is. And then this is just rewriting so the exponent's inside of that expression. None of that changed the value. So that means that this, let me put this in a different color, this means 1 plus tangent squared of t is equal to secant squared of t for all t. And because this is a proof, I always like to finish a proof with some expression or symbol that means end of proof. I like this one because that comes from Euclid's Elements. It's for quod erat demonstratum, or what I meant to prove. It's kind of it's the ancient Greek way of saying, in your face, I just proved it. Anyway, I had fun with that. Maybe you didn't have quite as much fun as I did, but I hope that illustrates the idea of what it means to prove a trig identity and a couple of techniques for doing so. Most notably, if you see something that's like a tangent or a secant or a cosecant, often putting it in terms of sine and cosine is helpful. And also, in this section, there's a lot that you're going to have to do that is just manipulating fractions. So you may want to review algebra with fractions. All right, in the next video, we'll prove another one of these.